physical data is very different than other kind of data. So it requires new sort of primitive all the way down. Right? You need a new storage format on disk. You need to index it in a different way. You need to handle how you query and manipulate it in a different way. So just sort of a whole thing changes.
This is a new thing in many ways. Sure, there's time series databases and so on has existed for a long time, but it's almost always focused on scalars, a single value moving up and down, or some text changing over time, text logs or something. But when you're in the physical world, you have these things, but also you have images and videos and audio and 3D meshes and transforms and so on. So you have very rich data, heterogeneous data, multi-modal data. Some columns are really thick, big images, and some are really thin with scalars. Some are captured at maybe a 10 hertz interval, take an image every 10 times a second with a high resolution camera. And then maybe you have an IMU sensor that's running at 2000 hertz or something. So you have very different data streams coming in.
The sheer data volumes that people are collecting here and the complexities that come with that mean that you need a completely new underlying data infrastructure. So what we've been building over the last couple of years now is essentially a completely rethought data stack for logging, ingesting, storing, querying, transforming, and ultimately training on this kind of data in a much simpler, much higher performance way than what people are doing today.
The essential problem is you have many data streams at different frequencies, and you want to look at what is the state of the robot or whatever it is at this point. And there is no the state because you have different states at different time points. So how do you sync these? So one way of doing it classically is just downsample the data to the lowest frequency. So if you have a 10 hertz camera, resample this 1000 hertz IMU sensor to 10 hertz as well, whatever. That's kind of sad. We've picked a different approach, which is all data is there. And when you do a query, you can do what we call a latest at query, which is kind of a forward fill. You get the latest value of everything. You can look at every row in your data, where row is some data came in on one of the streams here, and everything else will backfill into that. We can do that without wasting storage, right? That would be otherwise duplicating the same image 100 times. That's a bad idea for other reasons, right? We have this very sparse data set, and then we do latest at queries at it very quickly. And we do that both inside the viewer at real time, when viewing your data, but also on the data platform when doing bigger queries. To have a single data platform that handles all of these and allows you to view it and query it, store it and organize it, it's a pretty challenging area that we've attacked, but it's super fun.